Okay, so hello again. Welcome to the Cisco Community Live event. My name is Gabriela Godoy. I am a community manager of Cisco Community and host of today's event. Today, we are going to talk about Catalyst 8000 Edge Platforms Family Overview. Just before starting, I want to share with you to let you know that the Cisco Community is an online forum with over 500,000 members, where you can get answers to your technical questions prior to opening case with the TAC. You can answer many questions or can contribute and rate documents, videos, and blogs. The community can help you boost your career by becoming a top contributor and getting the technical community to know about your expertise. And now, another thing that I would like to share with you are the upcoming events and activities that are having place in the community. I would like to invite you for the second section of today's talk. We will host another event with Suman Mali, that's with us today, but this time he's going to do a deep dive on Catalyst 8500 series. This event will take place on November 17th. Please make your registration today through the link that will be published in the chat at this time. Also, we would like to invite you to become a community top contributor. For this, we invite you to participate in the community, not only in the events, but also creating content, documents, videos, rating things, collaborating, and answering questions. Well, take a moment to rate the content of your peers. In doing so, you will help us recognize the wonderful content that they contribute. How can we do it? It's easy. When you publish a question in the community or identify a helpful information, please help us giving a helpful vote. And if someone gives you a solution, mark it as accept solution. That it will help us maintain great quality content in the community. And also, we will give prizes to people that are helping others. Finally, I want to introduce you to our today's expert. Shamil Wamar is a technical marketing engineer for 4000 series integrated service routers, as well as Catalyst 8300 series. Shamil holds 4 CCIE certifications and is responsible for all things crypto on the routing platform. Shamil, thank you so much for your time and for being with us today. And Suman Mali is a passionate network enthusiast with 12 plus years of industry experience. He's currently working as a technical marketing engineer for Cisco 1000 series aggregation service routers, as well as Catalyst 8500 series. Suman is a hardcore quality assurance engineer with super escalation handling experience, which has shaped him into the network expert that he is today. Suman, thank you so much for your time. It's a great pleasure to have you presenting for us today. I also would like to say that we have some question managers that will help us to solve your questions. Thank you so much to all of you for your help in answering all questions during this event. So if you would like a copy of today's presentation, we are sharing the link on the chat for you, and you can download it. And just a final reminder here, the Q&A panel is open, so you can use it to publish all your questions. Let's start. Suman, I'm passing the presenter role. Just 1 second, please.
Thank you, Gabriel.
You have it. Thank you.
Hi. Hello, everyone. Good morning, good evening, and good afternoon. Cool. Thank you. So we are excited today to launch and introduce you Cisco Catalyst 8000 Edge Platforms family. They are here to redefine the WAN infrastructure. And let's start with a quick polling question. On your screen, you may see a polling option here. Gabriela, please confirm if the polling has started from your end.
Yeah, you can see it on the right side of your WebEx.
Thank you. Yeah. And the question that I would like to start today's session is with, what is Catalyst 8000 Edge Platforms family? I'm sure you have heard about it, and that's why you are here registered to this session. I'm curious to know how many of you know it. So you have 30 seconds more left for answering this. Are they switching platforms? Are they routing platforms? Or they are from wireless controller platform family? Please submit your answers. I'm curious to know what our audience thinks about Catalyst 8000 Edge platforms.
5 more seconds. You should be able to see the results now. We have letter A.
Wow. Do you see the percentage as well? Gabriela, is there a percentage of results like?
Let me see. It's available now. Let me open it. 25%.
Wow, it's interesting. So 25% of the audience has, I guess, clicked on that, but it's good to know that people think that Catalyst 8000 are switching platforms. So let me try to break the ice there itself. Catalyst 8000 Edge Platforms family is the next generation enterprise routing platforms. And today's session is about enterprise routing platforms, and we will be introducing you deeper with Catalyst 8000 Edge portfolio. So it's all started from 1993 when we had the first ISR platform launched from Cisco side, where the wide area network really took off. Let's have a quick video. You can play it in Zoom. Cool. That was a quick glimpse of last 30 years of Cisco's routing portfolio. The time has been passing so fast that we could not even imagine that so many platforms had been launched till now for serving the enterprise WAN edge. But this is a moment to take a pause and think about, are we ready for the new era in the WAN? Now that when things are moving with cloud specific deployment use cases, things are moving towards it from the data center to the cloud specific deployments. The WAN edge is getting redefined. Lot of traditional WAN routing use cases are going to change in coming days, and that's where we want to really introduce you with how our next generation Catalyst 8000 Edge Platforms family is going to take deeper and to the new heights of these new use cases. With that, we here have 3 new platforms as part of the Catalyst 8000 Edge family, starting with Catalyst 8500 series platforms, which are 2 1RU platforms, as you see in the picture, purpose-built for SD-WAN aggregation edge portfolio. The second one we have is Catalyst 8300 series edge platform, service-rich SD-WAN branch edge platform portfolio. We have 4 variations in this, 2 1RUs and 2 2RU platforms. 70 plus modules are supported in the form of NIM, SM, or PIM module. And the third important thing with virtual and cloud presence, either on x86 or VNF hosted hardware, We have Catalyst 8000V Edge software as part of the 8000 Edge family. It will be hosted in any of the public clouds that we have today. So this completes the family that we are launching with Catalyst 8000 Edge Platforms family, which is built for the new age intent-based WAN. And when I talk about the intent-based WAN, you might be recalling 2017 when we launched Catalyst 9000 with IBM thought process. Intent and context was a key message and key thought process on which the platforms were built by then, where a lot of things moving on the programmability dimension, where you talk to devices, not in traditional form anymore, but in the programmability aspects. That thought process then moved to the wireless with wireless controllers and 9100 and 9800 series platforms under the Catalyst portfolio. And now with Catalyst 8000 Edge portfolio, we take the Catalyst thought process, the intent-based networking thought process on WAN Edge also. This is the time where enterprise networks truly become Catalyst everywhere, IBM. A quick look at what's getting evolved. From aggregation point of view, we have ASR 1000 1HX and 2HX platform, which will be evolving into Catalyst 8500 series Edge portfolio. For modular access, we have ISR 4400 series, ISR 4451 and 4431 will be evolving into Catalyst 8300 series Edge platforms. On the virtual form factor, the Catalyst 8000V is an evolution of CSR 1000V and ISR 1000V platforms. Overall, all the use cases, all the orchestrations that these platforms will serve are optimized for SASE and the Cisco Secure Cloud Scale SD-WAN. One more thing, we just don't have the edge platforms to talk today. We have Catalyst Cellular Gateway as another entity being launched alongside the Catalyst 8000 Edge platforms. We will have this modular Catalyst Cellular Gateway module, which will support Cat 18 or 4G speeds orderable today. And in future, we will be having a 5G module where a cellular WAN can be hosted externally, where you get the WAN connectivity derived through this cellular gateway, and any edge device can consume it where there is no proper signal when you are hosting it next to a window or something. You will get proper cellular connectivity with this. So we're going to get introduced to all these new goodies. But while I call them out new, they are really not new. We have been vetting this for various customer use cases. Almost 30 plus EFT customers have already certified them for their use cases for SD-WAN as well as traditional routing use cases. We have 50 plus countries where these are certified already. We have 6+ months of beta testing. The early field trials were happening for these platforms, starting 17.2 and 17.3 releases. A lot of good feedback, as you notice on this slide. I don't want to get into in-depth of each of them, but want to give a quick glimpse on one of our critical healthcare provider, which really certified the Catalyst 8300 portfolio, they were able to take all the goodies that they wanted with respect to SASE use cases, the SD-WAN orchestration with high performing Catalyst 8000 platform that we have. So this is a quick note that we received from the customer. Wanted to highlight that to you guys. With that, let's get deeper into the meat of today's session. What we have today is Catalyst 8000 Edge platforms. First thing that comes to my mind is what are these new? What is special in these platforms compared to the existing ISR or ASR portfolio? Why do I think that these are better than any other platforms out there? So to understand all this, we first have to understand what are the key building blocks that these platforms are built upon. And when I think of them, the first thing that comes, and I want to introduce you to the quantum flow processor. The third generation of QFP is getting launched alongside Catalyst 8500 portfolio for the aggregation use cases. You might be already aware ASR 1000 platform hosted the first and second generation of QFP for last 12 years. It was a time when Cisco Express Forwarding was taken to the next level with QFP's centralized forwarding implementation. So when I talk about Ceph versus what QFP did dramatically different, okay, Ceph we used to have the faster forwarding with critical the fib, not necessarily depending on the compute part to take the forwarding decision. However, in QFP, we did implement the forwarding information at hardware itself. So all those lookups were pretty faster at nanosecond speed when QFP first generation was introduced. All the services from L4 to L7 we were able to apply at hardware speed just because of the QFP innovation. Okay, all that is good, but this is 10 years before, right? What's really changing today with third generation? Here, the same QFP takes a new approach towards forwarding by having cryptography done inline. We also have 240 Gbps of layer 2 aggregation possible within the same QFP ASIC. Just to get a glimpse of what it can achieve, we have 256K queues for your comprehensive QoS. We have deep packet inspection capabilities up to 80 Gbps throughput can be achieved within one single chip. You have inline crypto up to 137 Gbps crypto is achieved with the engines we have in there for 1400 byte performance. Ceph performance is also doubled, almost 200 Gbps from one single ASIC. Talking about sessions, I'll hold that talk for a few minutes because we are going to get deeper there. This is the block diagram of how QFP is built internally. We used to have the traffic management and packet processing engine components earlier as well. But what, as I said, added is the crypto and hardware assist capabilities. That is taking to the new level in the way the services are applied here. We also have this 240 Gbps L2 aggregation that we talked about, ingress and egress, L2 and L3 classifications, all done internally within the QFP itself. Let's get deeper step by step there in QFP, because this is one of the main building blocks for our aggregation edge. Multi-threaded parallel processing. You might have heard this term for past few years, like 10 years minimum, where ASR1K started. How that's getting done? In the packet processing engine block that you see in the middle here, we have 224 packet processing engines. Each engine has 4 threads. That means you have total 896 threads where 896 packets can be simultaneously worked at any given moment. Think of it and compare it to any CPU driven platform, like say for example the ISR G2 in the past. We used to serve 1 packet at any given moment, and now this guy takes it to 896 packets at any given moment, right? Almost 900% improvement there. So yeah, this is just the forwarding aspect. There is a queuing aspect attached to it, which is taken care by the traffic manager. And all of this happens in parallel. That's why we call it as multi-threaded parallel processing. 224 PPAs, 896 packets worked simultaneously. And with the help of 256 key queues, this guy is ready for serving the comprehensive QoS. Tremendous raw power there. Let's look at the second dimension, which is inline cryptography. We call it hardware accelerated IPsec for a reason. What you have here is a crypto block that consists of 16 crypto engines. Each of the engine gets its own resources from memory and compute point of view. So there is no race conditions happening when the crypto engines are trying to get traffic encrypted or decrypted. They have their own dedicated resources. Modularity is at the core of implementation. We also have hardware assist blocks dedicatedly available in the form of microclodes, which will serve a specific feature application. For example, NAT, firewall, IPsec, any of those complex services that we apply on this ASIC, they get their own dedicated microcode blocks for better scalability. All of this, again, we are able to deliver 137 Gbps of crypto performance for 1400 byte packet size. And should be crypto is supported with hardware assist capabilities. The third dimension of QFP is built-in layer 2 aggregation. We have proper mechanisms placed from flow control point of view, from ingress and egress classification point of view for L2 and L3 classifications within the ASIC for 240 Gbps port aggregation capacity. This helps us achieve that end-to-end flow control done from packet entering into the platform, wherein you don't need to have a dedicated IO chipset to really get the traffic aggregated and segregated before sending it to the data plane. But here the Datapath ASIC itself does all the packet IO aggregation, ingress as well as egress. Really helps us to get all that power delivered in that one RU form factor we are going to look into few slides for 8500. So totally the QFP 3.0 itself is an innovation which is taking the game from hardware-based forwarding to a totally new level in terms of doing inline crypto and layer 2 aggregation all within the same chip while doing the regular forwarding and queuing traffic management. While I talked about all the aggregation side innovation in Datapath, I really want to introduce you to the we have done in x86 multi-core SoC architecture. So this is system architecture we follow on our branch platform portfolio. Even ISR 4K platform, we had multi-core chipset to serve the data path and control plane. But here we are taking it to the next level with 8300 Edge platform portfolio. What we have here is an example of 8-core chipset. For example, let's focus on the left side here. We have service plane optimized 8-core chipset here. You get one control plane core as shown in the green here. You get 2 IO cores which are responsible for packet manipulation in terms of associating a packet with a thread and things like that. You get 2 dedicated PPEs, packet processing engines, which are responsible for applying forwarding features from ingress and egress point of view. And you have 3 dedicated cores for service plane cores. So this is an example of 8-core chipset which is orchestrated in service plane optimized mode. When I say service plane optimized, this is a mode that you can think of. I'm ready to serve any container-based services like say IPS URL filtering, AMP in case of SD-WAN as well as non-SD-WAN use cases. You can also host the KVM containers on these. So this totally is a default mode that we have for any 8300 platform. First, it will come in service plane optimized mode. But there can be a situation where, from my use case point of view, if I'm getting these services done, say for example in Umbrella Cloud via SIG termination, I may not want to host the local services. In that case, I can surely get the service cores realigned as data path cores in data plane optimized mode. So this is an innovation we are getting in x86 multi-core SoC architecture where dynamic core allocation will be possible. We're supporting this from 17.4 release where an user can customize flexibly. If he wants more services, I will boot the device in service plane optimized mode, which is the default mode. And if I want more data throughput, I will boot it in data plane optimized mode. That's really literally flexible, right? But we are not stopping there. We are taking it to the next level, introducing the DPDK for packet forwarding. The development kit data path libraries are really helping us to avoid some of the system calls. Just for an example, a packet being serviced from any IO interface, which when it comes to the data path, a feature has to work on the packet, and that packet space has to be accessed via a system call if there is no DPDK libraries involved. But what we do here is with the enablement of DPDK, we are able to achieve 20 Gbps of safe performance for 1400 byte packet size. All this is possible because the user space is directly from a network control, just use the pole mode drivers. So this really helps us to get the safe performance improved. But yeah, we also wanted to add power into crypto performance, and for which we have enabled QAT. The quick access technology is enabled on the multi-core SoC architecture, which is allowing us to have security and compressible acceleration possible, where all the crypto output is taken to the new level of 18 Gbps crypto throughput for 1400 byte performance. So you can totally imagine that these systems are purposely built for improved performance, both in the aggregation as well as the branch side portfolio with 8300 in branch and aggregation 8500 portfolio point of view. Okay, this is all hardware, right? This is all ASIC level, how we are implementing the data path. But all of this is really taken to the next level with iOS XE operating system itself. You might be knowing that last 10 years, iOS XE is there with ASR 1000 portfolio. 10 plus years now. It's 2008 is when it started. That 10 years or 12 years of investment in traditional routing feature innovations and the last 4 to 5 years of innovation with iOS XE SD-WAN use cases, all of them are readily available on day one just because the iOS XE is totally modular and programmable and open for porting it on the new platforms. So all the Catalyst 8000 Edge portfolio will get the features readily available on day one. Almost all level feature parity there. The next thing that we have is the single image. All the platforms that support SD-WAN today are able to host one single universal K9 binary image to either boot it in autonomous mode for serving the traditional routing use cases and boot it in controller mode for serving iOS XE SD-WAN use cases. So same image, you just turn one knob and you are ready to serve that specific use case. This is going to help our customers to accelerate the SD-WAN journey. Today, if I have XE deployed in a particular branch network, I can simply turn on a knob and get ready to serve iOS XE in the same place. No need to copy a new image, no need to copy or certify another code just for getting onto SD-WAN. Simplifies the deployments, and one good call out there is both modes we can effectively serve the zero touch provisioning, the day zero to day end operation services from programmability point of view. The code works seamlessly in both the modes when you are trying to enable a platform using automation services. A quick call out on trustworthy solutions as well. This is another well-known truth about Cisco products. We don't take security as chances. So it's at the core where we have all the Catalyst 8000 family is built with Trust Anchor module. Think of it as an hardware level certificate. So this chip helps us to load and authenticate the hardware, provides immutable device identity. We don't allow tamper hardware with this chip help. So what happens in step one here, the microloader from the TAM chip establishes the secure boot function to ensure only authentic and unmodified Cisco software boots up on that particular hardware platform. This mitigates advanced persistent threats and physical possessions and part replacement attacks, which can happen potentially, right? Having said that, after the hardware is confirmed, the firmware gets booted properly, where the ROM on boot up happens with the help of secure boot mechanisms. The third step we also verify is image signing solution, which has digitally signed the software that you are downloading from cisco.com and installing it in your router. That digitally signed software gets verified against the public and private key mechanism that we have inbuilt in the hardware and software there. So this is where you might see the sham messaging, sham match that is happening on the router when the router boots up. Okay, this is still the boot up level. My bring up is secured. Everything is made sure that it's all Cisco genuine hardware and software. We don't stop there. At the runtime defense in step 5 and step 6, we do make sure that the system is protected in runtime also from any attacks that can change the product software execution. Just an example, we have private configuration used and which gets stored in the encrypted format for all those RSA keys, and the private passwords that you may have in your running config is separately stored in an encrypted file. We call it as private config. Even for the virtual platform like Catalyst 8000V, we do have a secure object implementation. As you can imagine, in any virtual form factor, you may not have this type of TAM chip and hardware certificate because it can run on any x86 or VNF hosted service, right? But there also, we do get the secure object storage to help us assure that nobody can tamper the behavior of your software based on the running configuration you have there. So it's totally the security at the core is helping us enable those trustworthy solutions for any platform you choose from Catalyst 8000 Edge platform family. Yes, so these were the key building blocks we talked about, right? What makes Catalyst 8000 Edge platform special? What distinguishes them from any other router out there? We also thought about user as an important aspect when we thought about building the Catalyst 8000 platforms. To start with, we have incorporated RFIDs as another component on the chassis, which is passive RFID block. As you see, you might notice on the left or the right side of the platforms. 1 to 4 meters of read range. This does not require any power to run it. It is an ultra high frequency range and follows the ISO standards as well. This will help to have better inventory management from tracking point of view. The next thing we had is front panel hosted label tree. As you might be knowing, label tree is an important component where people want to know about the product ID, PID, and all those things from operations point of view or inventory management point of view. Usually we used to paste it on the top or the bottom of the chassis, wherein once you mount a device in a particular rack, it becomes tough to really access that label information. What we have here is a plastic strip which is hosted in the front side of the chassis. You can just pull out the strip like this. You will notice that there will be a QR code and the serial number and other information pasted on that particular plastic strip. So accessing the label information becomes easy just by pulling out this plastic label tray out of the chassis. A third important call out is ergonomics. We take this seriously. Pininfarina was an Italian design firm which helped us to define industry design language for Catalyst 8000 Edge platform family. They used to design Ferraris before. So you will witness this the first time you will notice any Catalyst 8000 Edge platform. We have circle pattern hex packing, helps us cooling the device properly from mesh structure that it belongs with. We do have same look and finish in the form of satin aluminum based textured finish. All the C8K platforms, you will notice that they have a same look and finish, as I said. And obviously from ergonomic point of view, rounded frames are made sure that every platform has this followed on either of the sides and the top and the bottom corners of the chassis. All these are the good things to know, fun facts, but they do bring in consistency in the way the platforms are designed. Yes, now is the time for the second polling question. How much of SD-WAN aggregate IMIX throughput you need per head-end platform? Please choose the answer this question. I am really interested to know how much of platform bandwidth you are looking for SD-WAN aggregation from IMIX throughput point of view. Is 5 to 10 Gbps sufficient? 10 to 20 Gbps sufficient for you? You may need more, 20 to 50 Gbps. All of these are mixed numbers. Please choose it based on that. And also let me know if you need more than 50 Gbps of SD-WAN IMIX at your head end.
We have 15 seconds more. You can find these polling questions on the right side of your screen.
Thank you. Please select your answer. These are very important questions for us. If you can help the answer with.
Okay, we have letter B with 16%.
Wow, cool. So 10 to 20 Gbps. Wow, then I have a right platform for you now. Thank you. I wanted to ask this question just before we dive into Catalyst 8500 Edge platform, which is there to aggregation of the SD-WAN portfolio. So this is the platform for SD-WAN as well as non-SD-WAN aggregation use cases. So that is the main reason. When you said 10 to 20 Gbps of SD-WAN IMIX is good enough, that excites me because these platform will deliver more than what you're requiring. Let's look deeper into that. If I have to tell 4 things about this particular platform to you as a takeaway, first is improved data plane. We learned about generation quantum blue processor. 8500 series is the platform that hosts the QFP 3.0. All that raw power of 896 threads is available in this platform. Second is accelerated SD-WAN services. We talked about inline, we talked about hardware assist blocks within the QFP architecture. That really helps us accelerate the services because they are being served in the hardware itself, within the ASIC itself. Third important thing is high-speed multi-cloud access. Today with the cloud use cases, the direct internet access or direct cloud access, this platform will offer you 100 gig, 40 gig, 10 gig and 1 gig port speeds to terminate any of your DIA, DCA use cases. Lot of variety and all of this in just one RF form factor. And the last but not least component is we are able to aggregate up to 8,000 SD-WAN IPsec tunnels. So this is just an example of scalability for IPsec tunnels point of view, where in one RU platform, you get to aggregate 8,000 branches or 8,000 remote endpoints for SD-WAN. But this also tells you like how much of the scale that can be improved on all other services. We will be looking at in some of those examples in coming slides. But these are the 4 key points that I would like to tell you today in terms of what are the new things coming up with Catalyst 8500 in 4 dimensions, so to say. First one, let's figure out where this platform will serve us in the networks, right? And that starts with they being purpose-built for SD-WAN aggregation. It could be either a data center hub or the large campus edge deployments. First thing, because now you know the key building block for this platform, the highly powerful QFP, the quantum flow processor, that enables the platforms to deliver highest SD-WAN performance we have. 33 Gbps of SD-WAN IMIX is possible through one 8500 platform. You have multicast replication performance, again one of the key highlight here, because all those 896 threads, they can really do better when it comes to multicast replication, because you have to replicate the packets in multiples when you are sending it towards your listeners. These number of threads we get as a raw power really uplifts the replication to new heights. This platform will be allowed for Headend multicast replication. All the SASE and cloud scale use cases that are there on SD-WAN today for ASR 1000 portfolio are readily available on these. The high we talked about new use case that's coming up today and like emerging because of the pandemic situation is remote workforce aggregation. The 8,000 tunnel scale really enables this platform to be a powerful and aggregation platform to aggregate all your remote work traffic. Within one RU, you can aggregate 8,000 remote workers. Just a quick example, right? So this small size is really taking the game to the next level. And when I small size, I want to highlight the next use case for this platform, which is co-location use case or the cloud scale CS, cloud MSP point of view, the edge and CPA use case. This is one of the key advantage of 8500s, where it's just one RU platform and which is capable of platinum grade power efficiency. So it takes less power, small in size, and it also has the port flexibility from 100 gig, 40 gig, 10 gig or 1 gig port operation point of view. This is just at the physical level, right? But all the rich features that we already talked about, multi-tenancy, VRF aware aspects, the VXLAN, the route scale, we support 4 million IPv4 and IPv6 routes on these platforms in the default memory. All of those goodness and the other feature L4 to L7 capabilities and the scale it serves is readily available on day one. This is one of the key reasons we feel that this platform will be loved for anything in co-location and cloud gateway use case. Either it's your CPE or the platform sitting on the head and aggregation or something sitting next to your cloud use case in co-location facilities. The next use case that comes to my mind is all those traditional routing things where we have been serving ASR 1000, 1HX and 2HX portfolio till now. All the 300 plus features on traditional routing, they are readily servable. Either it's data center interconnect, IPsec gateways, VPN aggregation, high-end NAT and firewall scale. All of these use cases with more flexibility because you get 40 gig, 100 gig built in, readily available to be served. No need of any other extra. With the use cases, let's look deeper into the platform itself. Starting with the scale, we talked about 8,000 SD-WAN tunnel aggregation. We talked about the port flexibility it gets in the 1RE form factor. IPsec, obviously inline crypto is taking it to the new level, but every port on this particular front panel, we support MACsec as well at line rate. MACsec is enabled by default. You don't need extra port licenses to enable MACsec or ports as well. Trustworthy solutions are at the core. We have umbrella SIG implemented. Edge compute is one more key thing where we have one dedicated core available for edge compute. You have integrated rich services in the form of NBAR, NAT, firewall features, and comprehensive QoS also all readily available. The platforms can be managed by vManage in SD-WAN use cases and DNS Center for traditional routing use cases. When you think about the PIDs, we have 8512X for QC and 8512X. Here the X stands for SFP plus interface capability. The platform here is a high density platform. The lower end platform we have in 8500 series, 8512X, which offers 12 10 gig bridges, which can also work in 1 gig speed when you insert a 1 gig transceiver. In the QC point of view, this also offers a 12 SFP plus interface. Apart from that, it has 4 QSFP interfaces in the middle. This 3 in the middle form Bay 2, and this one is part of Bay 1. So the first port in the Bay 1 and first port in Bay 2 can work in 100 and 40 gig mode also. So this gives us a flexibility in terms of how they can be consumed. To look into that more, you have to understand the 240 Gbps of QFP capacity port aggregation is divided into 2 buckets. We have 120 Gbps of port aggregation possible via Bay 0 and Bay 1 together. 120 Gbps of remaining port aggregation capacity is on Bay 2. This is how we get 6 different ways in which this platform can be consumed, or the front panel ports can be consumed. Let's look at that more pictorially. So in the first option, you can have 200 gig interfaces by enabling the first port in Bay 2 and first port in Bay 1 in 100 gig mode. When you do this, we have end-to-end path from here, the front panel till the QFP reconfigured in 100 gig speed. That way you get best experience from user point of view, because there is no multiplexing and things like that happening in the path. If you want to use it in 100 gig and 40 gig mode variations, you can have 340 gigs and 100 gig port. If you want 440 gig interfaces, you can have it in all the QSFP ports being used in the 40 gig, but you still get 8 10 gig interfaces apart from this in the Bay 0. In the fourth option, you get all the speeds. You get 100 gig in Bay 2, 40 gig in Bay 1, and 8 10 gig in Bay 0. Lot of flexibility there. Even when the platform is not modular, you still get a lot of choice in terms of how you can consume the ports. And both the platforms can offer high density 10 or 1 gig interfaces for consumption. A quick comparison on the previous generation ASR 1002HX on the left here, and the right side 8512X for QC. If I have to weigh them to each other, QFP 3.0 and the inline crypto with layer 2 aggregation on 8500 becomes a little heavier. We do have up to 64 GB DRAM possible here on 8500. All the ports are freely available. No port license required on 8500 side. You get built-in ports, no need of external EPA. The queues are improved. Datapath memory is almost 8 times more here with 8500s. Result is you get 16 million classic NAT sessions through one single 1RU platform here. 32 million carrier grade NAT sessions. You have 200 Gbps of Ceph we talked about, 46 Gbps of IMIX crypto throughput. This is IMIX 352 byte average packet size. And 33 Gbps of IMIX for SD-WAN with 8000 tunnel aggregation. Totally 8500 being this 1RU platform, pretty powerful with the QFP, is heavier when it compared with ASR 1002HX. Similar comparison with 1001HX versus 8512X platform, the lower end platform in 8500 series. It again gets the same hardware capabilities. All the 12 ports are readily available. Queues are the same. What you get is 12 million classic NAT versus 24 million CGN sessions, which were just 2 million and 4 million previous. You have 120 Gbps of Ceph here because you have 12 10 gig interfaces on the front. You get 30 Gbps of crypto as well, and 23 Gbps of SD-WAN IPsec with 8000 tunnel aggregation again. So all those people selected 10 to 20 Gbps of SD-WAN IMIX throughput at the head end. You have both the platforms capable to serve you those. A quick color on the TCAM capacity. If you have higher scale needs required for the TCAM, this is a memory which we use for complex features which needs quick classification lookups. Features such as access list, QoS, N-bar, firewall. That's where we use the TCAM in aggregation platforms. So we encourage you to think about the 8512X OTC platform, which has higher TCAM compared to the moderate one in the lower end 8512X platform. With that, a quick look at the block diagram that we have. This is how it is internally. This is how the port capacities are divided. So I told about bay 0 and bay 1 together can serve 120 Gbps because that's how they are connected to the data path internally in the QFP. And you have L2 aggregation of remaining 120 Gbps done with bay 2 interfaces. Crypto is part of the QFP itself. This blue block is the QFP. You have a dedicated TCAM connected to the QFP for faster lookup operations. The iOS runs as a process on the control plane processor here. Let's look at quickly on the packet path, how they get served. You have the ceph traffic directly getting served from the data path, from ingress to egress. Anything that is crypto now doesn't have to be sent outside the QFP because you have inline crypto. That's how we call it as hardware accelerated. We don't waste time in sending the packet out or in of the data module. It gets served readily. RP control traffic, again something that needs to be consumed by the iOS, gets to the control plane processor where iOS is running, and the response from that side as well. This can be your routing traffic and things like that. And the last but not the least, the multicast traffic. This is where the raw power comes to the help from the QFP. This platform will be the best to replicate multicast traffic. With that, I hand over to Shamil to take you through 8300 portfolio.
Thank you so much. Can you please?
Sure, Shamil. You have it. Thank you.
Hello, folks. Good morning, good afternoon, good evening. Very excited to introduce the new era of Access WAN Edge portfolio here. The best-in-class, all-in-one box solution for enterprise branches, the Catalyst 8300 series Edge platforms that can provide rich services and secure connectivity from your branch location to the cloud and to the on-prem data center. As Sumant already alluded earlier, the Catalyst 8300 platforms are the evolution of ISR 4400 series, specifically 4431 and 4451 routers. We'll talk more about positioning use cases along with the services richness and capabilities offered with these new shining toys. Okay. All right. Yeah. So these platforms are purpose-built for SD-WAN services, accelerated at the hardware, and these platforms are architectured with Intel x86 based system on a chip, which is basically a single CPU architecture with multiple cores distributed across control plane, data plane, and service plane operations. Dynamic core allocation is one of the key features that we will be introducing with 17.4 XC release, which Sumant has already explained in detail. So what is the special in 800 series Edge platform that makes it superior to ISR 4400 series platforms? So the major differentiator that I could highlight here or call out here in terms of a capability aspect, first is the 5 times performance for IPsec and ceph with hardware accelerator services. And how can this happen? Is because of the introduction of new component into the hardware architecture, which is basically the quad chip, the quick assist technology, as well as the data plane development kit, which is we call as DPD, and that is embedded into the hardware to boost the performance on this new 8300 series platforms. In terms of scale, we have much improved scale to support up to 6,000 IPsec tunnels on both traditional and SD-WAN use case. This is just an example. The scale has been increased for a lot of other features as well, but just to highlight here on IPsec tunnels. In terms of security, we do support a full stack of SD-WAN security, but what is differentiating this platform with ISR 4400 is these platforms comes with more services core in the service plane and now with better services performance. When we talk about 5G technology, all these platforms have integrated SIM slot for cellular connection and is future-proofed to support 5G technology in the PIM form factor, or it could be using an external cellular gateway device form factor. We'll be discussing more about in detail. And I cannot go beyond without emphasizing that we are the first vendor in the SD-WAN world to support the voice integration at the branch. So let's go through some of the interesting use cases where the 8300 series platforms can be positioned, and I'm specifically focusing more at the enterprise customer business networks on a secure SD-WAN edge. The 8300 series platforms provide full stack of branch security, whether it could be on-box security features like enterprise application firewall, umbrella security, or it could be container-based security services like IPS, AMP, threat-grade URL filtering. And now with our new offering with SD-WAN, we have the SSL proxy and AppQoE part of the offering. And what does that security services benefit you at the branch? Basically, it provides you highly secured end-to-end data flow between your branch to the hub or to the cloud. And we do support multiple WAN transport, whether it could be a private MPLS cloud, cellular connection over LTE, or it could be the direct internet access over internet links, could be Ethernet or via DSL modems. When we talk about zero-touch provisioning, yes, these platforms is centrally managed and provisioned with vManage for day zero bring up, day one for config updates, day n for monitoring and management for analytics, even whether the controller is hosted at the cloud or at the on-prem data center. As we all know, as per the current market trend, customers are adopting to cloud-based solution. We also call it as multi-cloud for hosting application in the cloud. And with multi-cloud, whether it could be software as a service or infrastructure as a service, we just rely on a single provider to host application or infrastructure at the cloud. So with Cisco, how can we provide best connectivity experience for our customers for securely accessing services at the cloud? For that, we need the strongest platform at the branch, which is again Catalyst 8300 platform, to provide high-speed cloud connectivity for SASE-based deployments. And with SD-WAN and umbrella stick integration, we offer cloud-based security at the branches for securely accessing applications for SaaS and customer infrastructure hosted in the cloud providers like AWS, Azure, Google Cloud Platforms. AppQoE with SD-WAN is another use case I would like to talk about. So this is application quality of experience. So how Cisco SD-WAN solution provides better quality for critical application for our customers. And what are the customer issues when it comes to application access? Some of the issues could be related to packet loss on WAN links, high latency on the WAN links, poor application performance with very limited application visibility. So how can we address customer concerns with our Cisco SD-WAN AppQoE offerings? So Cisco has introduced a lot of features a part of AppQoE, namely TCP optimization, forward error correction, packet duplication, and data redundancy elimination techniques as a container-based application solution to better optimize the bandwidth over multiple WAN transports for SaaS application and business-critical application hosted in the enterprise data center or cloud provider environment. Again, with these kind of deployments or designs, we still need a strong branch with a high-performing platform that can do strong AppQoE functions with better quality, application quality. And here we position the Catalyst 8300 series Edge platform. So this is a typical branch deployment use case for traditional routing. We have been familiar with many years now. So considering 8300 series as a branch WAN edge platform, what customer is going to benefit is the higher performance with much improved scale for commonly deployed features like routing, multicast, IPsec, NAT, firewall, and such. Split tunneling can be one of the use cases here to segregate traffic between trusted and untrusted, with MPLS being the primary for all the traffic or trusted only traffic, while customers can use internet for local internet access, or customers can deploy secure tunnels over internet or cellular transport to connect back to their enterprise data center in a backup use case. As I already mentioned before, we are the first vendor to have voice support at the SD-WAN branch. With 8300 series platform, yes, we support voice integration. Voice configurations can be orchestrated and policies can be pushed from managed, and that reduces the complexity with added capabilities such as web-based real-time monitoring. And with 17.3 release, we have introduced Cube, SRST, support for analog and digital voice modules. We have the next generation DSP farm. All these features have been introduced into this platform with the launch release 17.3.2. So if I want to explain about the key capabilities of this platform in a much simpler way, these are the 4 dimensions that explains it. The scale and performance I already talked about. The multi-layer security, as in like ISR 4400, we do support all sort of multi-layer security with the traditional and SD-WAN use cases, but now with more services core and better performance. When it comes to services richness, besides the full stack security offerings we have with these platforms are capable to provide AppQoE offering or AppQoE features like TCP optimization, folder correction, packet duplication to optimize your WAN traffic. When it comes to the edge intelligence, as we all know, there is a big demand to support many applications at the branch, whether it could be inside the service containers or it could be externally application hosted within the UCSC blade servers. And of course, the 8300 series platforms comes with increased compute capability for the application that it hosts. It's because of the more services core availability on the service plane, as well as the support for UCSC blade server to host external application that have its own computing power. When it comes to connectivity, these are the 5 key important points that I would like to talk about. First is we offer high WAN port density with 6 WAN ports on the front panel. And we do support 10 gig WAN MACsec 256-bit on all these platforms. The control plane DRAM capacity has been doubled to support 8 gig as the default and up to 32 gig as the max. And as already mentioned earlier, all these platforms comes with integrated cellular slot or LTE PIM module that is future-proof to support 5G technology when it is available. The pluggable NVMe storage is something new that we bought into these platforms in a storage form factor. So this is a thin, lightweight, a small slot module that supports M.2 based storage systems. And all these platforms come with 16 gig default storage with an option to upgrade to 32 gig or 600 gig options. And this storage can be used for requirements for the container-based application, or it can also be used as a loss storage requirement as well. From the manageability standpoint, this platform can be centrally managed from vManage for SD-WAN use case, and this platform will be available to manage it from DNS sender for a traditional deployment use case from day one, providing assurance and analytics capabilities using telemetry protocols. All right, let's get into more details. What are the different flavors of 83 series, 8300 series Edge platforms? So we have introduced two 2RUs and two 1RU platforms. I think it's very important for you to understand how to read the PID. So I will take you through one of the example on one of the 2RU platform, the PID naming. So C stands for Catalyst, A stands for Platform Series, N stands for NIM slot, S stands for SM slot, T stands for 1 gig, and X stands for 10 gig. So if you want to read it, read the PID, it's Catalyst 8300 with 2 NIM slot, 2 SM slot, 4 1 gig port, and 2 10 gig port. Similarly, on a 60 platform here, as an example, we support 6 1 gig port on this 2RU 1 gig platform. And we have 1 gig and 10 gig offerings on both 2RU and 1RU platforms. As I mentioned earlier, the 2RU platform, we support 2 NIM slot, 2 SM slot, 1 dedicated PIM slot. And for the 1RU platform, we support 1 NIM slot, 1 SM slot, and we have a dedicated PIM slot on the 1RU platform, not on the front side, but it's on the rear side. The 42X model on the top half of the picture, those are the platforms that support 10 gig, and the 60 models on the top of the picture are the platforms that support 1 gig. So these are the M.2 external NVMe or USB-based storage modules that I have already explained about. Along with the platform, we have also introduced the next-gen WAN and layer 2 Ethernet switch modules. So we have introduced the 1-port 10 gig module that support 1 gig and 10 gig speeds. And also we introduced the UADP 2.0 Docker ASIC-based layer 2 switch modules in the 22 ports and the 50 ports size. So what are the key capabilities that we introduce into these modules? On the switch module is that these modules support multi-gig for LAN connection, and also we have introduced 10 gig ports for uplink connection from these switch modules. And moreover, these switch modules can be managed directly from the router operating system. When it comes to user design, Sumant has already talked about all these platforms comes with RFID for remote device tracking, and we have QR label tray, that's a plastic strip that provides you rich information about the device externally, and the internal redundant fan units on all these platforms. And all these platforms comes with a redundant power supply with AC, DC, and high voltage DC support with a default front to back airflow. And for customer who requires reverse airflow, we do support NIPS DC power supply units on the 2RU platforms as well. And we do have PoE boost available with 500 watt and 1000 watt AC power supply units. So let's quickly weigh ISR 4451 on the left here against the 8300 2RU platforms on the right to compare their capabilities. If you look at the 8300 2RU platforms, it has been offered in 12-core and 8-core variables with hardware crypto assist. And you get additional 2 ports, could be 10 gig capable SFP plus or 6 1 gig SFP interfaces with 2 NIM, 2 SM, and 1 PIM slot to uplift the modularity on 8300s. The default DRAM doubles to 8 gig default and is upgradable up to 32 gig, helping higher route scale on 8300s. And with improved hardware, we are able to achieve 900 Mbps of services throughput, comparing the 240 Mbps services throughput on ISR 4451. And obviously, with set capacity, is way better, reaching 20 Gbps and a crypto capacity support up to 7 Gbps versus 3.8 Gbps Ceph and 2 Gbps crypto on 4451. And we are able to achieve 5 Gbps of SD-WAN IPsec throughput for Ergonomics profile compared to 1.4 Gbps on 4451. Biggest plus point being the tunnel scale that goes up to 6,000 IPsec tunnels versus 4,000 IPsec tunnel in ISR 4451. So when we weigh ISR 4431 on the left against 8300 1RU platforms, the 8300 1RU platforms comes with 8 cores CPU with hardware crypto assist, and added additional 2 gig or 10 gig ports availability on the front panel with an additional 1 dedicated PIM slot. The DRAM capacity is the same as with 2RU, 8 gig default to 32 gig upgradable. When it comes to services performance, we do have almost 5 times performance, like 600 Mbps on 8300 1RUs, comparing with the 150 Mbps on the 4431. In terms of set capacity, this platform can go up to 15 Gbps of performance, and we have 5.4 Gbps for crypto, comparing to 3.4 Gbps for Ceph and 1 gig crypto on 4431. In terms of SD-WAN IPsec, we support close to 5 Gbps on 8300 versus 750 Mbps on 4431. And in terms of scale, the scale remains the same for 2RU and 1RU platforms, 6,000 IPsec tunnel support for SD-WAN and traditional use case versus 3,500 IPsec tunnel on ISR 4431. Okay, so let's quickly discuss about backward module compatibility. So we support most of the modules which are being supported on ISR 4400, except the one highlighted in the asterisk at the bottom. And what all the modules support on ISR 4K and compatible with 8300, customer can reuse those modules when they want to migrate from ISR 4K to 8300. So the modules we highlighted here is not capable with 8300. So what we did is we introduced better capability, new generation modules on the WAN, LAN, cellular, and the voice services side. And on all these new modules, we will have the SD-WAN support from day one. WAN AppSec is supported on the WAN module and the layer 2 UADP 2.0 based switch modules for MAC layer security. And on the voice side, we have introduced new DSP voice modules for DSP form in the NIM form factor with 32, 64, 128, and 256 voice channels. Okay, so now we have another polling question here. What are the different module types you are using in your ISR 4K branch locations? As you all know, our portfolio is modular. We support 70 plus or more than 70 modules in our modular portfolio products. We have ISR 4Ks, and now we have the new 8300 series platforms. So it would be good to understand what are the different modules that you have with your ISR 4K positioned at your branch locations. And you have like 20 seconds more to complete this polling question.
Okay, 3 seconds more. Okay, now you can see the results. We have letter B.
Letter B. Okay, so that's cool. Yeah, so switch modules. Yeah, that's very good because we have our portfolio with the integrated services solution that support various modules, and switch module is one of the important thing like customer would like to do for having switching capability on these platforms. Yeah. Thank you. Okay, so here are the list of modules that we support on Catalyst 8300 series platforms. 70 plus modules. The modules highlighted in the blue are the new modules, and most of them are already launched along with the Catalyst 8000 series platforms. And you can see asterisks on some of the voice and the WAN module here. What does that mean? Is we do not support this module for SD-WAN deployment at this moment, and it's part of the roadmap. And we do only support on traditional iOS XE deployments. And the 5G PID highlighted here that comes under the LTE category, those are part of the roadmap. The black highlighted modules listed in this page is the one module. They are the modules that are currently supported on ISR 4K and is now compatible with Catalyst 8300 series platforms. So let's discuss about the life of a packet on Catalyst 8300 series platforms. So some of the key components I have highlighted here in the slide is the DPDK and the QAD chip. That are the new components that we have introduced to actually boost the performance on these platforms. So let's take a quick look about the packet flow inside the hardware for various components. Basically, the NIM and the SM module to data for data traffic, the I/O ports to the data plane for data traffic, the IOSD to the data plane for control and routing traffic, the service plane to data plane for container, native, and KVM-based application, and we have the LTE SIM to the data plane communication for data traffic, and finally we have the crypto packet is being forwarded to the quad chip for decryption and encryption, and sent back to the data plane for processing and vice versa. So the 8300 2RU and 1RU life of a packet is same, except that the models has only one NIM and one SM slot with 110 gig for NIM and 110 gig for SM for backplane connectivity to the data plane. With that said, let's have a quick look about the Cisco's cellular gateway offerings on a high level. This is not a module based, but it's an external hardware, exactly looking like an access point with antennas. But here the use case will be for extending the cellular WAN connections. So this hardware support dual SIM with improved speeds for LTE. And this can be used as a primary or backup transport for the branch with gig and multi-gig support on the service side. This hardware acts as an IP pass-through device that the IP from the cellular provider is bridged to the router WAN interface connected at the other end for extending the cellular WAN connections. And it provides flexibility to position the gateway closer to a window outside the branch closet for improved cell tower coverage. And this hardware comes with PoE capable ports, and that can be powered via Ethernet cable without dealing any expensive or complicated power socket installation and extensions. This hardware comes with Cat18 support, and it's orderable now. The 5G support on this hardware is part of the roadmap. And finally, this hardware can be managed separately using Web UI or a CLI from the router for traditional use case, or from vManage for SD-WAN use case. And with SD-WAN, you will be able to push configuration on cellular parameters using vManage templates. So now I will talk about our new virtual portfolio, which is Catalyst 8000V. This virtual portfolio will be introduced in 17.4 XE release, and this will be our future virtual aggregation in the multi-cloud environment like AWS, Azure, or Google Cloud. And also, this virtual portfolio can be installed on the ENCS hardware platforms as well, and can be positioned as Access WAN Edge, a virtual Access WAN Edge. And these platforms are evolution of ISR-V and CSR-1000V with 100% feature parity with more flexibility and elasticity embedded into it. These slides talk about virtual router convergence. As you all know, in 17.1 and earlier XE releases, we had to have 4 different iOS XE operating systems, which means 4 virtual routers to address SD-WAN and traditional routing use cases. And starting with 17.2 and with 17.3 XE release, with unified image support, customers were able to run both SD-WAN and traditional routing for each CSR-1000V and ISR-V in a single binary file. And now with 17.4 XE onwards, we will unify all the ISR-V and CSR-1000V feature functionality into single Catalyst 8000V image. In that way, customers can deploy a single virtual router, which is Catalyst 8000V, that addresses cloud, co-location, on-prem, and virtual branch use cases. So let's quickly talk about some of the use cases. First thing I would like to call out is branch to cloud connectivity. So customers can deploy Catalyst 8000V in the branch on ENCS hardware platform and connect it to 8000V in a transit network in the cloud. And this provides consistent user experience as the same iOS XE router is connecting the customer from branch to the cloud. Second use case would be a transit network gateway across multiple clouds. So customers can now provision a transit network hub in both Azure and AWS with the advent of virtual WAN solution. And this is the next step in a true multi-cloud solution, as customers can use the latest cloud innovations in the cloud marketplace to connect their SD-WAN fabric. And with most widely adopted hypervisors like ESXi and RHEL-based KVM, we continue support of ESXi 6.7 and RHEL KVM 7.5 in both traditional and SD-WAN use cases, and now can be deployed in customer on-prem data center or co-location facilities. With multi-services support and platform elasticity, the Catalyst 8000V is capable of running both iOS XE and SD-WAN modes while providing the same flexibility and elasticity of an x86-based VNF. You will be able to allocate as many virtual CPUs, memories, and interfaces as you need, and can be easily scale up and scale down based on your network requirements. And with cloud integration, as I already explained earlier, Cat 8JV is available on all the major cloud marketplaces and can be deployed within minutes to provide secure and high-speed connectivity from your on-premise network and to the cloud, and can be fully integrated with AWS Transit VPC and Azure Virtual Network Solution. And with multi-layer security, it enables SASE-driven virtual enablement via secure object group, high-throughput IPsec, and full stack of embedded security services. From the manageability perspective, for the SD-WAN use case, it's managed, and for traditional use case, DNS sender support is part of the roadmap. Okay, so 8000V, it retains the same feature and platform parity with CSR-1000V. The major new additions that we have introduced with the Catalyst 8000V are defined here. The secure object store, the ENCS NIM support, SD-WAN support on Google Cloud Platform. We have introduced the Azure Virtual WAN integration support with 8000V, and we have also introduced the new way of licensing, which is the DNA licensing with smart licensing enhancement. The Catalyst 8000V will also maintain the same throughput parity with CSR 1000V, and we are expecting the AWS performance to reach up to 35 Gbps IPsec aggregate throughput for the large instances with 1400 packet size for traditional deployment. And with Cisco SD-WAN, with Azure integration, you can deploy Cat 8kV as a virtual SD-WAN hub. And we expect 8000V throughput can go up to 10 Gbps with 1400 packet size. And that's for SD-WAN. And for the non-SD-WAN use cases for Azure, the IPsec traffic at 1400 byte can theoretically go beyond 10 Gbps of throughput. Okay, let's glimpse into what we have discussed so far as a key takeaway from this session. So here is the key takeaway from the session. The Cisco Catalyst 8000 Edge Platform family is extending high performance SD-WAN in Headend, branch, and cloud edge. We discussed about the first 100 gig and 40 gig 1RU SD-WAN Headend, which is the ATP100 series Edge platform, which is empowered by 3rd Gen QFP for inline and high performance services. We talked about the 10 gig branch with rich connectivity, modules, and services, with the introduction of Cat 8300 series Edge platform that provides multi-layers full stack security on-prem and in the cloud. We talked about edge intelligence with high-speed ports, high port density, and multi-domain integrations. We talked about the Catalyst 8000V software strong presence in the public cloud market to provide multi-cloud architecture, simplification, and application optimization. We talked about the future 5G ready branch for high-speed cloud access over cellular. And all these platforms are built with user-centric design to bring platform consistency and user operation consistency across the family. So the Catalyst 8000 Edge platforms joining the bandwagon. Cisco has the broadest set of SD-WAN platforms, as you see in the picture, giving you a lot of flexibility and to choose the suitable platform for your use case. A truly broad set out there for SD-WAN underlay orchestration. To know more about Catalyst 8000 series, platform family, and cellular gateway, Cisco Cellular Gateway, we have added a few slides with external reference to the data sheet, FAQ, ordering guides, and we have some community blogs, which is internal and external. So please take some time to access these URLs and learn more about Catalyst 8000 series Edge family portfolio, on what are the services and the offering that we are providing with the introduction of these new shiny toys. And with that said, I'll hand over the ball to Gabriela.
Awesome.
Thank you so much for the session.
Thank you so much. To note, our presence in social media keeps expanding. So we encourage you to visit the Cisco community and to join us through these channels. Also, we continue to expand our reach in many different languages. For hubs, we have one already available in a language of your choice. These are not simply translate sites, they are active standalone sites in native language. Looking for more information on IT and technical training, log into the Cisco Learning Network and take advantage of the technical webinars that they offer. Go to the link provided in the chat to learn more. And before sign off, please take some minutes few minutes to complete our evaluation, and this will help us address your business needs and interests in the future. Also, as a token of appreciation for having attended this event, you can redeem your 35% discount at Cisco Press by entering code CSC when checking out. So this concludes our session today. Thank you so much, Suman, Shamil, our experts, and all question managers for sharing your expertise with us today. Also, thank you so much to the team who helped us to organize this event. Thank you. Have a great day, evening, and we see you on the community.
Thank you, everyone, for attending the session today.